Hi everyone. Sorry that you will not be having this lesson with me in person. However, I hope this video is rather helpful and will help us save some time as well. So 3.7 deals with solving different percent problems. We're going to be using the proportion method as well as the equation method. To start, we're going to deal with proportions since we just dealt with that in 3.5 and 3.6. And I'm hoping that many of you have heard of this proportion that will help remind you to deal with percent problems. And it is over of equals x over 100. And now this x over 100 is always going to be the percent that's given to you. That's what x will always stand for. If I don't give you a percent in the question or the statement, then you leave x as a variable. Is and of are what we're going to translate to the different values that we have in the equation as well. Normally, you can go with the number around each of the words and place that in the numerator or denominator. So in this example here, you might be given a question. Sometimes you're given a statement. It says, what percent of 82 is 15? This of 82 would go in our denominator for our is over of fraction because we're saying of 82, and of is in the denominator. Then our is 15 would go in the numerator. And again, that's where is located. For our next proportion, I'm asking you what the percent is. So I don't have it. So our x remains in the numerator, and then it is x over 100. To solve our proportions, we just cross multiply as we've been used to doing. So we'd have 82x is equal to 1,500. And then we go ahead and solve for the variable, and we would get roughly x being equal to 18.3. Normally, I like to give questions where you're not getting a decimal, you'd get a nice integer or really a whole number. For the next example, I gave us 26 is. That 26 is goes in the numerator of our first fraction. Then I gave you the percent, 4%. That's our x, or the numerator of the second fraction. And then of what? I don't know what that of is because I'm asking you what it is. So my variable drops into the denominator where of would be. We would go ahead and cross multiply to have 4x equals, sorry, I'm not too great with writing with this, 2,600. And then we go ahead and solve for this variable, and we would get 650. That seems reasonable because 26 is a very small percent of that number, so the number should be pretty big. And just to show you the last one, we have 2%. So again, that's the numerator of our second fraction. The order of the fractions doesn't matter, but I just try and be consistent and write them the same way over and over again. Then I have of what number? That of what? I don't know what it is, so that's my variable. And then is 49. That goes into my numerator. And once again, we cross multiply as we've been doing with our proportions. And we would get that x is equal to 2,450. Again, that should make sense because 2% is really small. So 49 is only 2% of a really big number. The other examples that you could possibly use are using an equation. This method is pretty nice to use as well because you go ahead and just translate the question or the statement word by word into either an operating symbol or keeping the number as it is. Now, in these examples, you have to remember that you have to change the percent to a decimal. You do not have to do that in the proportion method. So in this example here, to translate this question into an equation, we have what percent. I don't know what that what percent is, so that would be my variable of x. Remember back to the beginning of the year, of means to multiply. The numbers stay as they are. Is means equals 27. So our equation really is, to write that a little bit neater, 103x equals 27. We go ahead and solve for the variable by dividing by 103 on both sides, and you're going to get a small decimal of about 0.26. Since I'm asking you for a percent, think back to our summer quiz. To change the decimal to a percent, we move the decimal point over once, twice, to get 26%. For the next example, I gave you the percent, but we have to change it to a decimal. So to change a percent to a decimal, we have to move the decimal point over once, twice to the left. So our 3% is going to turn into 0.03. Of means to multiply. 39 stays as it is. Is means equals. And what? I don't know what that what is, so my variable goes there. This one's a little bit easier because we have the two numbers that we're multiplying together on one side. So we don't have to solve for the variable using inverse operations. So we can just go ahead and say 0.03 times 39, and we're going to get x is equal to 1.17. You do not need to change this decimal because we weren't solving for a percent. In this following example here, we have a little bit different setup again. We have 103. Is means equal. Our percent, we have to change that to a decimal, so we're going to move it over once, twice to the left and have 2.4. We have our of for multiplication, and x is what we don't know. If you want to rewrite it so your variable and coefficient are right next to each other, that would look like so. And then you're going to use your inverse operations to solve for x. And you are going to get 103 divided by 2.4, which is about 42.92. And to finish the last example of this lesson for this page, we're going to go ahead and translate again. We have what is, so we don't know what that is, and is means equals. 59% as a decimal is 0.59. Of means to multiply, and we have our 120. Again, this is like the second example. We can just go ahead and multiply those two numbers together, and we would get 0.59 times 120. So x is equal to 70 point, oops, that looks like a comma. That is a decimal, 70.8. I hope that you go through the rest of this PowerPoint. There's just some extra examples here for you to look through. There's some guided practice examples. There's a word problem that we're going to use a chart for. And again, some more examples for the equation method. These notes are posted on the portal under 3.7, Solving Percent Problems. And in your next class, you'll be completing a worksheet dealing with these different examples.